Okay, so I want to try number 4f and 8.2. So this is inverse Laplace transform 3s plus 2 over s squared plus 1 times s minus 1 quantity squared. Okay, so first things first, what do you want to do? Yeah, it's the same thing.
Partial fraction decomposition.
Dude, where did you ever come up with that idea?
You just told me.
No, I told you to do the same thing.
That was the same thing.
Oh, okay. So, yeah, hit this with PFD, right? So take your thing out, 3s plus 2 over s squared plus 1 times s minus 1 squared. Okay, so I'm going to try to write that as,
This is the part that.
okay, so I have to remember two things, right? I have to remember how quadratic ones work and how repeated linear ones work. So first things first, go through and find your single linear factors and put constant over that things.
Okay.
I don't have any of those.
So the quadratic
Okay, so the quadratic, s squared plus 1.
is an x plus b.
AS plus B.
Yep, so you'd put a as plus b over the top of that. Good with me? Okay, now, is that going to be something that's in my table? Yeah, it's not one thing in my table, it's two things in my table, right? Like, this part with the as is a cosine, and that part with the b is a sine. You guys with me on that? Okay, but I'll be able to deal with that. And this is an important thing to do when you're setting these up, right? When you're setting up your partial fractions, make sure that you're not wasting your time. Like, check that each piece is something you know how to do, or something that you're going to have a plan for how to deal with. Like this one, I don't know how to do this one directly, but I can break it into two pieces. I know how to do the two pieces. Then, how do you deal with the linear factors?
C over S minus 1.
Okay,
Plus D over S minus 1 quantity squared.
nice, perfect. Okay, now the c over s minus 1, that part's going to be chill, right? That's going to be an e to the t, right? Maybe times a constant. This guy? Is there one of those in there?
Oh, that's just going to work out to be a
Like a S minus 1
cosh,
squared.
or no, a cinch, right?
So if you go check, I'm looking for s minus something to a power, right? So if you scroll through your oh, there's a t to the n, e to the at in there. You guys see that one? Okay, so this one I can get using the t to the n, e to the at. This one's an e to the at by itself, and this guy's a sine and a cosine. Okay, so I'm going to know how to do each of these. You guys cool with this? So now you find your common bottom. So you're going to have your 3s plus 2 is, let's see, so I got the as plus b, what does that guy need?
S minus 1 quantity squared.
That needs an s minus 1 quantity squared. So you got as plus b times s minus 1 squared. Okay, now I've got a plus, and I've got my c. What does c need?
S minus 1 and then S squared plus 1.
C is such a crappy variable choice. I'll change that to an e. And that needs a s squared plus 1 and a
S minus 1.
s minus 1. Guys with me on that? Okay, and then this last dude needs a
S squared plus 1.
just an s squared plus 1.
So are we going to get funky heaviside things now? If we.
Yeah, so if you try heavy sides, some stuff will kind of get weird. You could give it a shot. It's not a terrible idea. So if I was going to try heavy sides, I'd be like, okay, So obviously if I evaluate this thing at s is 1, I'm going to have a good chance of solving for d, right? But if I try evaluating where s squared plus 1 is 0, I'm going to get all sorts of wackiness. Also, I can't evaluate where s squared plus 1 is 0.
Yeah.
At least not without stepping from magic land into complex number magic land, which is really a place I don't want to spend too much time talking about. So I'm going to evaluate at, so I'm going to take this equation, which I'll call star to be boring. So I'm going to get one variable at least by taking star and evaluating at s is 1. You guys with me on that? I'm going to get somewhere. So when I evaluated s is 1, I get 5 is 0, 0, 1 squared plus 1 is 2, I think.
2D.
So I get 2d. So I got d is 5 over 2. False. Right? Okay, so now there's other options for how to do this. But the one I would recommend is you just pick some other points and force agreement.
S is 0.
Cool. That one seems like a good idea. So you take star, evaluate at s is 0.
Only 0 today.
So you're going to get 2, right? Oh, and I should put 5 halves in for d, right? Since I know that now. So I put s is 0 and I get 2 is b times 1 plus e times 1. Oops. Minus 1. How about b times 1 times minus 1? And then plus 5 halves. Okay, so that one I don't need, that one I don't need, that one I'm just going to write here. Okay, so I got this other equation. That's got b and e in it.
So now we want to find something else with B and E in it.
So now I want to find something else with b and e in it. So oh, but I'm not going to be able to get rid of a,
Yeah,
right?
only
You
kill
guys
A
see that?
with 0.
So like, you guys see why Heavyside's method is kind of like getting dorky with me here? So do you all remember the other method, just in case Heavysides gets super annoying?
A huge set of
Yeah, you multiply all this junk out and then equate coefficients. You guys want to see that trick, or should we continue dorking with this? It's all you. Pick one. Pick one faster.
the normal way. It's probably-
No dorking.
Okay.
Let's pick whatever gets us there faster.
Okay, so let's multiply and equate coefficients because we haven't done that in a while. You could force this to work. Right? If you evaluate at 2 more points, you'll get 3 equations and 3 unknowns. You plug that crap in a calculator, get it to ref a matrix, check, done. Right? You all know how to do that? Are you smiling and nodding at me right now? Okay, cool. If you want me to teach you how to ref a matrix, let me know after class. Otherwise, multiply this crap out. So you got 3s plus 2 is, let's see. I got as plus b times s squared minus 2s plus 1. And then I got e plus e times, multiply,
S squared plus S minus 1
s cubed minus s squared
plus S minus 1.
plus s minus 1. And then that one's pretty easy. And I get to keep the 5 halves, right? Okay, so I do a little more. I need to FOIL that one out some more. Oops, I lost that. I got it down there. So I got my 3s plus 2 is, let's see, so I got as cubed minus 2as squared plus as plus bs squared. That one's appropriate, minus 2bs plus b. And then I got a plus es cubed minus es squared plus es minus 1 minus e, thank you. And then I got a plus 5 halves s squared plus 5 halves. Again, I wrote this in this kind of dorky way because I'm hoping
You lined up all your exponents.
that I lined up most of the exponents. I didn't quite get there, but I tried. So I got s cubes, right? How many s cubes you got on the other side? None. So you got a is minus e. Right, that's a plus e is 0. So that was from the green one. Okay, next.
S squareds.
S squareds. So you got s squareds here, 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 and there. Hooray.
Minus 2a plus b.
So I got minus 2a.
minus 3a? Or no.
I'm not going to make this sub yet. But, so I got minus 2a plus b minus e
Plus 5 halves.
plus 5 halves equals 0. All see that? And then we could shove our minus e in for a and maybe combine like terms and stuff. We'll do that in a sec. Let's see, what else have I got? I got s's, right? So s's, s's, s's. How many s's? Oh, there's s's over there now. Good. Okay, so my yet another equation is a minus 2b plus e is 3. Oh, and that one I'm going to deal with right away because I know a plus e is 0. Okay, so that tells me b is minus 3 halves, which I should like indicate for later.
Which you can cram back into the other one.
Yeah, which I can cram back into the other one and figure out that guy in a sec. And then what else have I got?
Constants.
Yeah, I think I got this other equation that's b minus e plus 5 halves is 2. Do I need that one?
No, because you can already figure out them all from what we have.
Yeah, I think I can figure out everything from what I've got here. Why did I get lucky like that? Like, why didn't I need the other equation?
The heavy set.
Yeah, because I did that heavy set thing to put that 5 halves in there. Otherwise, you'd have another variable there and you'd need to figure it out.
I mean, it'd make it easier to figure out, to be fair.
What's that?
B minus e plus 5 halves equals 2 is really easy to figure out.
Oh, yeah. Probably this is the same
Yeah,
thing,
it's,
though, right?
it's,
This and that should be the exact same equation.
yeah.
Like up to rearrangement anyway. So a is minus e, so I got 2e minus e is e, plus b is minus 5 halves, and b was minus 3 halves. Okay, so that seems to say that e is 5 halves plus 3 halves. Oops, minus 5 halves plus 3
So
halves.
E is
So minus
1.
So e is minus 1.
So a is 1.
And thus a is 1. So collecting bits, I have a, b, e, and
And
d
you're gonna
was
do 5 halves.
a long time ago somewhere. But
In erased land.
in erased land, which is a neat place. Okay, so you do all this partial fraction decomposition, then you go back to where you were.
Carefully do not erase your numbers.
Yeah. Carefully don't dump the stuff you need. And then here, right, I'm saying, all right, from the beginning, I'm going to PFD this thing. So I'm going to end up with the inverse Laplace transform of A was 1, B was minus 3 halves, E was negative 1, and D was 5 halves. Cool. I probably made an arithmetic error in there somewhere. Who cares? All right, so then you use linearity, right? And when you use linearity, I have one further thing before I use linearity. This part,
Two things.
right, I should really break up into its two things. So that's s over s squared plus 1 plus minus 3 halves over s squared plus 1. Cool. So now if you use linearity, you get the inverse Laplace transform of s over s squared plus 1 minus 3 halves the inverse Laplace transform of 1 over s squared plus 1 minus the inverse Laplace transform of 1 over s minus 1 plus 5 halves the inverse Laplace transform of 1 over s minus 1 quantity squared. Okay? And then you say to yourself, who needs partial fractions anymore? I'm done with that. Yeah, and then you say to yourself, self, I recognize most of these things. Right? You say, the first one is a table. Cosine of what, friend?
Just a 1 t.
Of t by itself. Okay? Then I got minus 3 halves. What's 1 over s squared plus 1's inverse Laplace transform?
Sine.
That's sine of t. Boss. Then I got a minus
E to the t.
e to the t. And a plus 5 halves.
It's going to be
No. That one's not exactly like that in the table, is it? Is that one exactly like this in the
that
table?
was okay. Because 1 factorial is 1.
Is it n minus 1 factorial on the top?
Yeah,
Uh,
and it's n plus 1, which is 1 plus 1.
Okay, so,
Yeah.
yep, that's exact. Damn it, I was really hoping, I should have put a cube here, but the inverse Laplace transform would have been a disaster. Okay, so this one just so happens to be 1 factorial, right? Okay, so I don't have to add any factors, that one's exactly in there. And that's a t e to the t or minus t?
Just
Right.
t.
T. Cool?
T. Yeah.
Checked on? Cool. That took forever. Right? But was there anything actually hard in this?
Not really.
You just have to remember how to partial fraction decompose, right? And then not screw it up.
Organization.
Yeah, and
That's the hard
what I was showcasing up here, kind of bad organization, right? You guys see that? If you want good organization, do that thing I was doing where I was stacking exponents, and just get it right. I got 2 terms in before I decided I was going to use that method, and so I missed a little bit. Cool? All right.